Welcome to this video series on frequently asked questions about the Java language. In this ongoing series of videos, we'll answer commonly asked questions about the Java language. You'll come away from this video with a solution to the question that you as a developer may have. In fact, these questions have been asked by thousands of developers, so you're not alone. Our approach to every question is simple. First, we pose the question about the Java language, Java development, or best practices. Then we fill in any background material so the question makes sense. Next, we'll get into the details of the question and discuss it further. Then we'll come up with an answer. As a bonus, we'll go deeper on the answer and look at a code example showing you what to do and in some cases, what not to do with a counterexample. Stick around until the end of every video where we'll discuss the solution from an application security point of view. We'll let you know what to watch out for to ensure your code stays secure. For more videos like this, like and subscribe to be among the first to know when we release something new. Ready to get started? Let's go. So the question we address in this video is, how can we do a string to date conversion in Java? Let's say that we have a string like the following. We assign the string variable myDate equal to the string January 1st, 2020, with the month January written out in all text. And let's say we want to parse our string to read the month, the day, and the year. How can we do that? In contemporary Java, we can make use of the class java.time.format.datetime-formatter. In order to read the string January 1st, 2020, we need to create a pattern that represents the data that we'll be parsing. In our example of January 1st, 2020, we can represent that pattern like we see here with 4 M's, followed by a D, followed by a comma, and 4 Y's. Let's look at each of these symbols in our pattern and see what they mean and how the data will be interpreted. First is the capital M for month. 4 M's means the month of the year. The number of M's determines how the pattern is expected to look. Less than 4 characters, that is less than 4 M's, will mean our formatter class will expect a shortened form of the month name, for example, Jan instead of January. Exactly 4 M characters will mean that we expect the full form of the data and the month spelled out completely. Exactly 5 M characters means that we expect the narrow form of the month. We'll see what that means when we get into the coding section of this video. Continuing with our breakdown of the pattern, next let's look at the D. The symbol D indicates that the string should contain the day of the month. It's a lowercase d. A single lowercase d is fine for either 1 or 2 digit days in a string, so either January 1 or January 25, for example, will work equally well when only 1 D is specified. If a string uses 2 Ds, it will work for double-digit days of the month, like 25, but will fail with a parser exception for single-digit days, like 1. If an uppercase D is used, it represents the day of the year, so a number between 1 and 365 or 366 for leap years. Next on our list of symbols used to parse the original string is lowercase y. Lowercase y symbol represents the year of the era. The number of y's should match the number of digits in the year. For example, 4 y's will represent a 4-digit year, and 2 y's will represent a 2-digit year. An uppercase y is used to parse for a week-based year, ensuring the year has whole weeks that can span into the next year. This is a bit of an unusual circumstance that might be used for fiscal applications, for example, in an accounting or government application. Java has evolved considerably over the years, and there are often different libraries capable of accomplishing the same thing. This is definitely true when it comes to dates, times, parsing them, and converting them to and from strings. Let's take a look at some more features from the date-time libraries. First, in code you may maintain as a developer, or review as a security analyst, you may see the older Java API for date and time related matters, which has been around since Java 1.1. This library is effectively obsolete and has been superseded by a much more robust library. The older library should not be used for many reasons, including the fact that it's not thread safe. Many of the methods have been deprecated, meaning you'll get compiler warnings when you use them. And the locale is not set correctly in these older libraries, which can lead to hard-to-debug parse errors in your application. Many good things were introduced in Java 8, including major updates to the java.time API. It includes the ISO 8601 standard for communicating date and time values in a standard way that supports international differences, and how dates and times are represented. Some of the packages included in the new API include java.time, which includes classes for date, time, time zones, instance, durations, and clocks. Java.time.chrono, which represents calendar systems other than ISO 8601. Java.time.format, which has classes for formatting and parsing dates and times. Java.time.temporal, which supports interaction between all classes. And finally, Java.zone, which has classes for time zones, offsets, and time zone rules. Okay, let's switch gears and take a look at some code. I've got a project created in IntelliJ IDEA running on a Windows 10 environment. Let's start by creating a class called string-to-date-conversion. We use the PSVM shortcut from IntelliJ to create our main method. Let's create a string called myDate and initialize it to a value of January 1st, 2020. Now let's create a variable called dateTimeFormatter of type java.time.format.dateTimeFormatter. We'll use the of-pattern static method and pass in the string 5 m's, a single d, and 4 y's. Next, let's create a variable called localDate of type localDate. Let's click Alt-Enter to add the import statement. And we'll use the parse method to parse our myDate variable using the dateTimeFormatter pattern we specified. Now let's print out the value of the month, day of the month, and the year. We'll use the SOEF shortcut to create a printf statement. First, we'll print the month, so we add the text month followed by a colon and %s to indicate that we'll be displaying a string. Note that I should have used the %n character sequence instead of the /n that I have here. We'll use the getMonth method from the localDate object to print out the month. Next, we'll print the day, so we'll create a printf statement once again. Add the day, colon, and %d to indicate that we'll be printing a numeric value. Then we'll invoke the getDayOfMonth method from the localDate object. Finally, we'll add another printf statement and add a year, colon, %d, and the getYear method of the localDate object. And let's execute that code. When we do, we get an exception. If we look at the message, it says the string January 1st, 2020 could not be parsed at index 1. If you recall from our earlier discussion, 5 m's indicates the narrow version of the month, rather than the full month name as we have here, while 4 m's indicates the full month name will be parsed. Let's remove one of the m's and execute our code again. This time we get the expected value of January. Now let's change January to Jan and rerun our code with no additional changes. When we do, we get an exception again. Looking at the error once again, we see that we get a parse exception on the value of myDate in our date string. Recall from our discussion of date formatting earlier in the lesson, less than 4 m's represents the shortened form of the month. Let's remove one of the m's to make it 3 and rerun our code. When we do, we get the value of January as a result, even though we had only specified Jan. Now let's add back an m and change our date string so we only use the character J to represent January in our date, and rerun the code. Now we get a parse exception once again, since we clearly violated the formatting that was expected. Notice that what we have here is now the narrow form of the date. As we mentioned earlier in the lesson, 5 m's would be necessary to parse that value. So let's add an additional m so that we now have 5, keep the J as it was before, and rerun the code. Well, it's kind of a good news, bad news scenario here. Our code worked, but it gave us the month of July rather than the month of January that we've been using. Note that in the English language, January, June, and July all start with J, so just using a J in our date is quite ambiguous and should be avoided. Now let's change our date format completely and specify 15:01:2022 as our date. And correspondingly, let's change our pattern to reflect the change that we made in our date format. We'll make it a lowercase d, which specifies the day of the month, capital M for the shortened form of the month, and 4 U's. Here the lowercase u simply represents the year. When we run the code, we get back the expected date of January 15th, 2022. Now let's add 2 D's instead of 1, and rerun the code. When we do, we see that it works just fine. And if we make it 1D again, we see that the code still works fine. Now let's take out 2 of the U values, so we only have 2 U's in our pattern, and rerun that code. When we do, we get a parsing error like we saw at the beginning of the coding lesson, because our format doesn't match the exact number of characters in the year. When it comes to security, are there any concerns around string to date conversions or dates in general? Perhaps surprisingly, there are a lot of concerns around the use of dates and times when it comes to security. If your code uses the older pre-Java 8 versions of the date libraries, there's some concerns to be aware of. Because the libraries are not thread safe, it's possible for the data to be shared among multiple user sessions. This can cause intermittent problems in your application that will be extremely difficult to debug. Always pay attention to the compiler warnings around deprecated code. They're there to help you prevent these kinds of issues. For more detail, look at CWE 488, Exposure of Data Element to a Wrong Session. Another CWE to review is 362, Concurrent Execution Using Shared Resources with Improper Synchronization, or simply race condition for short. Both 488 and 362 are related to multiple threads sharing the same piece of data. Related issues may include time of check, time of use issues, which is another race condition and is a known vector for exploiting vulnerabilities in systems. When updating existing code or reviewing code as part of an application security review, pay attention to date-related activities in the code. Although most of them are completely innocent, they can be used to trigger logic or time bombs in code. Code can be added by disgruntled workers who can trigger it to run or fail to stop it from running at a certain time if some condition is met or not met. For example, if they're fired, they may not be around to prevent the logic from running, so some logic bomb may go off that does significant damage to an organization. Although the logic bomb may be traceable back to the individual who implanted it through the software configuration management tool where the code is managed, this is little comfort after the fact when the damage is done. Remember that in matters like this, you're not always dealing with a rational actor who can think through the negative downstream impacts to their own lives should they do something like install logic bombs in their code. For more information on this topic, take a look at CWE 511. Thanks for watching. We hope you enjoyed this video. Please like, subscribe, and share this video with others. To get our free ebook on how to write more secure code in Java, go to www.beginsecuretraining.com. When writing code, always remember to begin secure.